Hi, I'm Graham Steele, Head of Product for Cyber here at SandboxAQ, and today I'm joined by Nina and Sandra from our research team, and we're going to talk about FIDO 2. So what is FIDO 2 and why do we care about it?
So FIDO 2, also known by now as Passkeys, is a cryptographic protocol that wants to get rid of one of our security issues, which are passwords. So passwords are really a burden on the user. You have to select a good password, you have to store it, you have to memorize it. And so the FIDO 2 protocol, or Passkeys, wants to get rid of this burden. And so what they're doing is to log into a website, you're using a hardware token. It is an NFC token, so you put it against your phone and then you log into a website.
Mm-hmm. So I didn't have to use any password, I just need that little bit of hardware, I need my phone and I can log in. Okay, awesome. Well, this sounds great. So we do a bunch of interesting things here at SandboxAQ, but why are we particularly interested in this?
So at the core of SandboxAQ's mission is a modern and agile cryptographic solutions. And so this agile and modern cryptography is not only for software, but it's also, we need to include hardware. And these keys, they also need to be upgraded, they need to be migrated to be PostQuantum secure. And so FIDO 2 or Passkeys is a key example of a protocol that needs to be migrated to be PostQuantum secure.
We want to help this standard get ready for the post-quantum world where we're under threat from a large-scale quantum computer that can break the public key cryptography we use today. And we're helping out with that effort to get this standard upgraded. So how are we doing? Is it difficult?
So the first thing that we need to take into account is that when considering modernizing the cryptography that we use to make sure that we are resistant to quantum computers, we will need to update those algorithms, those cryptographic algorithms, and potentially this can be either slower or they may require more space. No? So when thinking about hardware solutions, hardware security solutions, like for example these ones, we need to take into account that this kind of hardware is usually something that is kind of constrained. No? In order to make sure that the costs are under control. No? So any change that we do in the cryptography used by these hardware devices can actually impact on the user experience. No? And well, I guess you don't want to wait 5 minutes, for example, for authenticating to a service. No? So it's important that we start looking at how is this impact going to be. No? And in order to do that, we have published the first open source library that allows to test the impact of this post-quantum cryptography across the different entities that participate in the FIDO protocol, because it's not only the piece of hardware, the hardware authenticator. It's also the application that runs in the mobile phone or in my browser, and also the server that is behind, the server that we want to authenticate with. No? So what we have done is we have created this library, this repository, in order to be able to test the end-to-end flow and how this will be affected by the post-quantum cryptographic algorithms. And we didn't build this repository from scratch. We actually took parts of code that were already open source, no? And that were these building blocks, and we updated them or we modified them in order to add these post-quantum cryptography primitives. And for example, for the case of the code that is running in the hardware token, in the authenticator, we took the Trust library, which is an open source initiative for running this type of code. And then we took Mozilla's implementation for the browser and an open source implementation of a server running a FIDO 2 protocol from Yubico.
Okay, awesome. So this is, I guess, available on the SandboxAQ GitHub, is that right?
Yeah. Exactly.
Okay, so anybody can download this, can play with it, can try some examples. But what should people do if they want to get involved?
So we welcome them to actually look at and use it in their frameworks, to download it, to play with it, to experiment with it. And one of our next steps at what we would like to do is to find out what post-quantum algorithms should be used with it. So at the moment, it uses one particular post-quantum signature scheme and a key encapsulation mechanism, namely dilithium and kyber. that are also selected by the National Institute for Standards and Technology to be standardized as post-quantum algorithms. So our current open source implementation uses these post-quantum algorithms. But there are other signature schemes and out there that might be even better suitable for this. And so we are inviting people to also use other algorithms, or we are also planning to benchmark other algorithms and see what are the differences in the efficiency in the data communication and the size of the data that is communicated and things like that, and to then guide maybe decisions that are taken to update the specifications to also include post-quantum security.
Right, right. So I guess in the end, everyone has to do it the same way because it's a standard, right? It's an open standard and people can implement to that standard. So we're hoping that this work is going to help us get to a better PQC FIDO2 standard, more or less.
Indeed, yes. And so the FIDO Alliance recently published a white paper where they are addressing the quantum threat. And so what they're describing in this paper are essentially two steps. First, select the right post-quantum algorithm, and also to then provide or ensure a smooth transition to post-quantum security. And so these are very much two things that we also would like to contribute. The selection of the post-quantum algorithms, and then a smooth transition, maintaining cryptographic solutions that, right, again, at the core of SandboxAQ's mission. Right?
Awesome. Okay, right, great. So if you want to find out more about the work we're doing on FIDO and you want to, for example, download that code, try out that open source framework yourself, we're going to make sure there's a link to our GitHub under the video. If you've enjoyed the video, don't forget to subscribe to the SandboxAQ YouTube channel so you don't miss any more videos. And it just remains me to say thank you to Nina and Sandra.
Thank you, Graham.